1407 lab. So this is lab 8, saponification of fatty acids. Actually, what is that saponification? We're making soaps today. So, Miss White?
Oh yes, so I have a story about soap. As you can see here, in making soap, our reagent is vegetable oil. So there's a tribe in Africa called the Maasai tribe, and when a young man comes of age, he has to prove that he's a warrior. What happens is he will go out into the wilderness and try to come back after they kill the lion. When they're out in the wilderness, they can't take a shower that often, so they'll take animal fat and rub it on their body and then wipe that off, and that's how they'll stay clean. Am I saying you're cleaning your body with fat? Yes, because you can see that vegetable oil, which is a fat, is the major ingredient in making soap.
So, making the soap. This is a saponification reaction, base hydrolysis reaction. Why we say that? Because the sodium hydroxide, the base, reacts with the vegetable oil, or more specifically this triglyceride, and producing a glycerol and the sodium salt of that fatty acid part. So that is the soap.
Okay, in the mechanism, essentially, as it says, base hydrolysis. The base is sodium hydroxide. Hydrolysis means breaking apart. The part of the bond in the vegetable oil that breaks apart is right here. And so the mechanism is, the base here will separate into NaO and then H. So this part here is positive, this is negative. The NaO will come and attach itself right here. So it will be like NaO, and you see that in the product right here, NaO, right? And then the H plus will come and attach itself to this H. And that is how the base breaks apart this fat molecule. The H is attached to the O to make the glycerol. Then the NaO goes over here. You can look at it as ONA. Over here, and over here. So for every reaction we have, we get 3 times the amount of soap.
Now in the soap, as you can see, the sodium that attached to it, of course that's the polar part, the polar end, and the stearate, we say, the fatty acid part, is the non-polar part, non-polar end. So how this soap works, how it attracts the dirt. So this is the oil, and these are the polar ends. We call it micelle. So a micelle with the polar end gets attached to the water part, and the oil will get attached to the dirt. That's how the dirt, the non-polar part of the soap, that's how it detaches the dirt and cleans anything.
Yeah, your body. So essentially what happens here is most of the dirt on your body is greasy and greasy oils. So the designer, the scientist, which could be you, will have to make sure that the soap has got two ends. The polar end interacting with water, the non-polar end interacting with dirt. So the non-polar end will not only dissolve the oil, it will trap the oil in there. So you can see the oil cannot seep out. It's completely surrounded by the non-polar tails and trapped in there. And then the exposed ends of the soap is the polar ends. And they kind of huddle together. And as you're rinsing off the soap from your body, picture a commercial. Somebody's rinsing off. These come off together like this. And they're all moving off of your body, right? And so the molecules of soap work together in a very coordinated system to get the dirt off your body and make you clean.
So that's how the soap works. And the lab will be of making a soap and to see if the soap is of good quality or not. Some tests.
You will not use this soap on your body.
Yeah.
Let the real scientists in the lab who have been hired and vetted to make sure that they know what they're doing make this soap. You can use the soap you buy from the grocery store or wherever, but for this soap that you're making, you're just trying to make sure that it's actually decent and it will work as a soap, but you will not use it on your body because it might end up being too dry and irritate your skin.
Exactly. So that's the gist of the lab. Okay, putting the vial and the cap on the balance and tearing, then using the pipette, take about 2 grams of vegetable oil.
Oh, that makes sense. The density is much lower because I'm saying that whole dropper is less than 1 gram. There you go. Okay.
It's about 2 grams of vegetable oil and about 2 ml of sodium hydroxide. So, as you can see here, there are 2 distinct layers, oil layer and the sodium hydroxide layer. Then, let's shake this vial vigorously. Then we can wait for 10 minutes to see if it separates again. Keep doing this until there are no distinct 2 layers. Mix it well, and we're going to keep this for 72 hours for the soup to make up.
So we'll be back in 72 hours.
So I hope after the mixing, 72 hours, let's see if you got what the oily part you got at the top, is it soap or not? First of all, let's filter out this layer. So I've got a filter paper folded in a beaker. Let's pour the whole solution. See, the thick part, upper part came out, but not the whole thing. What you do? We're going to use the sodium chloride solution to salt out this whole mixture. So I have here about 4 ml. I'm going to use it half first. So let me take about 2 ml. That's about 2 ml. Mix it. This is called salting out. So the sodium chloride is supposed to salt out the soap from the fatty acid mixture. Let's see. Let's pour it down again here. It's supposed to be soap. That's it. Filter out. So the residue you will get on the filter paper, that's the soap. Let's mix it again. Salting it out. Filter it again. All right. Let's wait for this to filter out, and on the filter paper, the residue, that will be the soap. And make sure to let it, dry. So it might keep it rest for overnight. It might take some time. So while you keep this your soap, the whatever you made, make sure when you filter it out, make sure to empty out all of the content in the vial. You can see I've kept this filter paper over this paper towel, and you can see it's quite oily though because of the oil layer still in there on the vial. And if you can't get as much as this much is fine. Now according to the lab, it says you can take about, if it weighs to about 0.5 gram, is good. So I've taken a beaker, the plastic beaker, tear it, because if I can tear it, then I can take about 0.5 gram of the soap. Let me try to take a little bit of from here. Use this. Let's see how much I have here. Yeah, 0.1. So whatever the amount you get, there you go. So whatever the amount I got. So within 72 hours, the amount you get. So this is your soap. Make sure to write down the mass of this, how much you got. Here I have purified water, 50 ml. Let me prepare a mixture, a soap mix. Let's mix well. Make sure to mix all of the soap that you got filtered out from the vial. So now what I'm gonna do, take 2 test tubes, 1 and 2, already marked. In each of it, take about 5 ml of this soap mix. Alright, now what else we're gonna see? We're definitely not gonna use it on our skin, like how well it washes, no, because we don't know the pH. What if it's too basic? It's gonna make your skin too rough. So let's see the pH. How are you gonna understand, is it basic or not? Let's use a pH paper. Okay, let's take a pH strip. There you go. You can use a little bit of it. And let's see. Let's use a steering rod. From here, you can tell how basic it is. Okay? So make sure to write down your observation, how strong it is. All right. Now, let's do another thing. Let's see how much it foams out. So vigorously shake this, the mix. If it forms a good layer of foam like this, whatever you get, make sure to take a photo of it, and then we're gonna see how it reacts with 2 different things. The vegetable oil, how is the layer, and another one is hard water mix. All right. Okay. Let's add about 2 drops of vegetable oil. This. Shake it again. And see what you got. All right. Make sure to take a photo of this. It'll be different for each person. Okay.
want to add, this part, like I'm preparing this. This is easy. So it says to mix all of it. Okay. It says to pour it into the beaker that the soap mix in here. Why did I pour it here? Would it matter that much? Okay, already mixed. Good. Why transfer it again? Could have said just make it then. So about 20 drops. I took the vegetable oil through this. I cannot use it again. Let me bring. Okay, this part. Right. See? Let me bring just another dropper. Okay, I'm ready. So it's filming, right?
Mm-hmm.
All right. Okay, so next, let's use the hard water mix that was given into the lab kit. Pour it into a beaker or a glass, plastic glass that was provided with the kit. Add about 50 ml of water in it. Make sure to mix it well. We're going to test how the soap reacts in this hard water mix, this basic solution, how it reacts. All right, how much I'm gonna take? The test tube 2, let's take about 20 drops. There you go. Let's shake it. Because soap supposed to remove the chemical substances that makes the water a hard water. So, see the foam layer formed? It'll be different from each person based on how much of soap you got, what's the pH, but make sure to take a photo of the foam layer formed and write it down on the data table. And after that, make sure to clean up everything as it was instructed in the lab kit. So that's it for the saponification of fatty acid for the soap. Thank you.